Hi everyone. Today we're going to add a new type of sequence to our repertoire. We're going to add the geometric sequence, which is a set of numbers separated by a common multiplication or a common ratio. So we learned last time that arithmetic is it goes up or down by a constant through addition or subtraction. Now we're going to multiply. And we can multiply by a whole number or a fraction. In this case, the geometric sequence 4, 8, 16, 32, 64, 128. The multiplier is 2. And sometimes I'm going to see the multiplier right away, and sometimes I'm going to have to calculate it. So geometric sequences are going to look very similar to exponential functions. So we need the first term, we need the multiplier, so it's like ab to the x, except it's the first term times the multiplier to the n minus 1. And then recursion is going to be the same thing. Okay, we need a term, and then we also need an equation that tells us how to get from a step to another step. So we're going to write an explicit formula and a recursive formula for this sequence. The first things first, I got to look at it, see, is it arithmetic, is it geometric, is it neither? And I look and see, okay, I think I know the multiplier. Okay, the multiplier is 3. My first term is 5. I'll write those down. Okay, it has to multiply by 3 every single time. The same change has to happen, and it does. So now my explicit formula, right, very similar to how I wrote exponential. So T of n equals my first term times 3 to the n minus 1. So the n minus 1 once again is my first term. And my common ratio or my multiplier is 3. Now the recursive formula, okay, I tell it to get to the next step, I need to do 3 times the last step. So if I want to get from step 1 to 2 or step 2 to 3, I take 3 and multiply by whatever where I am, and I get to the next spot. And then I got to give it a starting spot. So in this case, I give it, okay, term 1 is 5. And I could say term 1 is 5, or I could say term 2 is 15. Any piece of information, any term is sufficient. And we're going to see that in the next problem as well. So we're going to write an explicit formula, recursive formula for this sequence. Now, this looks kind of close to arithmetic. We're subtracting 4, we're subtracting not 4. So it's not arithmetic. I have no idea. 16 times what gets us 12? 12 times what gets us 9? So what I'm going to have to do is figure that out. So I do know that term 1 is 16. Good, useful information. Term 2, I can do 12 divided by 16, or 9 divided by 12, or 6.75 divided by 9, and see that the ratio of new over old every time is 12/16, or 3/4, or 0.75. It does not matter if you use the fraction or the decimal or simplify the fraction. We just need a ratio. It can be in any form we like. And now with the first term and with r, we can write our equation. So T of n equals 16, which is our first term, times our ratio to the n minus 1. And in here could be 0.75, or 12/16, or 3/4. Get in the habit of using all of them and understanding that all of them are possible. And then the recursive formula, once again, to get to the new step, I do 3/4 times my old step. See here, I used a fraction. And then I got to give it a term. I got to give it a starting point. Okay, in this case, I'm going to say term 3 is 9. I could say any term I want as long as I pick one of the terms that I know to be true. I can go forwards or backwards from term 3. From term 3 to 4, I can multiply by 3/4. And if I wanted to go backwards, I'd have to multiply by the reciprocal and go 4/3. So that's what you need for recursive and explicit formulas if we're dealing with geometric sequences.